Hey guys, so today what we're going to be going over is ways to expand exponential values. So we have an example here where we have e raised to the a plus 3b quantity squared. When I look at a problem like this, I'm going to see what looks very familiar to me, and what I'm going to notice here is I have this binomial term, and what it's asking me to do is to expand the problem as much as possible. So in order for me to expand it, I have to break that apart somehow. So when I do this problem, I'm going to write out the e, and because I have a squared term, I'm going to be multiplying the a plus 3b by itself again, just like that. And we know now a way to go ahead and take care of this, and the next step is to then distribute. So now let's just go ahead and just take care of business here. So when I distribute this, I'm going to distribute each term through into every other one. So when I distribute out, I'm going to get an a squared plus a 3ab plus a second 3ab plus a 9b squared. And now when we can combine these two terms here because they have the same value, I'm going to have here e raised to the a squared plus 6ab plus 9b squared. Now when you did the problem, you noticed here at the bottom you had e, a little box, times e, another little box. That box is a little more like a trapezoid. And then I have another e times the box. But I have it in this form. Well, how do I turn it into this form? And this is when our laws of exponents come in. So when I'm doing my laws of exponents, so I make laws not look like learn for you. And what we're going to see is that if I have a 2 here squared multiplied by a 2 cubed, what this is really telling me is when I have 2 squared, it's just like here where we had the a plus 3b and I'm multiplying it twice. I'm going to do that same thing here for the 2's, and then I'm going to do the same thing here for the 2 cubed, where I'm going to have 2 times 2 times 2. And what we can see here is that I get a 2 raised to the 2 plus 3 power. And we then get a 2 to the 5th. So when I go and look at this problem here, I can make some correlations and say, okay, my original problem here has a trinomial, so I've got one term plus another term plus another term, and I've got a term plus a term here. And because these are equalities, I can go either direction here. And now I can say, okay, I have this form, but the problem's asking me to put it into this form here. So now I can take this form and say, because of this law of exponents, and what that tells us is whenever I have 2 bases that are the same multiplied, I then add the exponents. So we're then going to go the opposite way and break it apart, where we've got e raised to the a squared times e raised to the 6ab times e raised to the 9b squared. And that's what our final answer is, and that's what you would plug into these values here. So we have a squared, sorry, I have to kneel, I'm a little too tall for this. And then we're going to plug in the 9b squared, and that is our final answer. Yes, Janet, we have a question.
So how do you know down at the bottom it has to be that order? I change the order of the e's on the bottom there?
You don't have to change the order. The great thing about order of operations is that I could rewrite this as e to the 6ab plus a squared plus 9b squared, and they're exactly the same. So it doesn't really matter the order. It's just for this particular problem, it makes it easier if you need to go backwards to realize, okay, that is a squared term, that's a squared term, and I can get a perfect square term in the end if I needed to go the opposite direction. Yes, Nick.
Now, I've seen in the past, sometimes I multiply when I'm in the exponents. So I never remember when do I add that 2 and the 3, or I multiply the 2 and the 3. Sometimes I get really confused about that. So is there a way that I can remember this without memorizing it?
A great way to remember is that the 2 here, with 2 squared times the 2 cubed, they have the same base. So I can do this with any type of letter, variable. It could be a star, a rainbow, star, horseshoe, or a balloon. It doesn't really matter. We're just going to use an x here. I've got x squared, and I'm multiplying that by an x cubed. Because they have the same base in this rule, I can then add the exponents to get my 5. The flip side is that if I have a sum, then that's it. I can't simplify that anymore, and that's just our answer there. Yes, Janet. Or Amy, go ahead.
At the very beginning, when it's still a plus 3b squared, why can't I do a squared plus 3b squared?
That's a great question, Amy. So again, we're going to go over here now. And the reason why that's because it's a distributive property. And what I'm going to have here is we're going to have a equaling 1 and b equaling 2. And we're going to take that same term, a plus 3b, quantity squared, and we're going to plug in those values. So I'm going to have my a value of 1 plus my 3b, which is the 2, squared. Now if I just take this and go and say I'm going to just square this first term and square this second term, I'm going to get a 1 plus a 36, which equals 37. That is not correct, though. What we see is that we need to do what we call PEMDAS, and we all remember that from, I believe, our algebra classes. Sorry, that's supposed to be an E instead of an M. So what PEMDAS tells us is we have gives us the order on which to solve problems, where we have the parentheses, the exponentials, the multiplication, division, adding, and subtracting. So we're doing that same thing here, where I have to make sure I'm dealing with what's inside the parenthesis first. So I have this same problem, 1 plus 3 multiplied by 2, quantity squared. I'm going to take care of the parenthesis first and then do that, so I get a 7 squared. And then I'm going to do the exponential value, which gives me my 49 as my answer. And we can tell that they don't equal each other here. And that's why we have to make sure to be careful. Instead of just squaring this term and then that term and then adding them, you're missing this middle term here, which plays a big role in your final answer. And you can look ahead to see the path that you need to take. I need to have 3 answers here, okay, and then if you just do the a squared plus 9b squared, you realize I'm missing a term. Okay, great. Thank you guys so much, and I'll see you in the next video.